Okay, hello everyone and welcome back to a new session, Computer Science 2, MCS 2514, summer semester 2022 at Lawrence Technological University. Today we are at week 1B. We're gonna go over chapter 5, loops and files, and chapter 6, functions. We're gonna go over these in brief. If any of you wasn't in Lawrence last semester or in Computer Science 1 and you need more explanation or more info, send me an email, send your questions, and I'll be more than happy to answer them. So I'm gonna go over them as brief as I mentioned, just so we review the info that we need for the digest of this semester. After test 1, those topics would be the digest of this course. Everything before test 1 is a review. So before I move on to chapter 5 and 6, in chapter 4, there is a topic 4.14, which is the switch statement that we didn't go over. So I'm going to go over it again in a brief as well. So a switch statement is similar to an if statement, but it has more into it. So a switch statement, you can, instead of having nested ifs or nested if-else statements, like if this, else if that, else if that, a switch statement has one block that covers all the possible cases that you have. And at the end of that block, there's a default case, meaning default case for cases that aren't covered in the previous cases. So the syntax for a switch statement is simple. I go ahead and say, for example, let's say I have a choice that the user chose. So I'm going to ask the user for a choice, cout, enter A, B, or C, for example. Then I'm going to read into my variable. Then I can either do the if, else statements. If user choice equals A, do this. Else, if user's choice equal B, do that. Else, do that. Or I can use a switch statement, which switches the control flow into a specific case. That's why it's called switch. I can switch based on my variable or the user's choice in this case. Then I can explicitly say, if the case is A, do something, right? If the case is B, do something else. Case C, do case C. Then I have a default case. Here I can just say, for the case, for the sake of demonstrating, you entered A. I can do the same for B. I can do the same for C. B, C, and the default you entered something else. If I run this as is right now and enter the case A, in this case, all these cases are gonna execute because I didn't stop the execution. In order to stop the execution, I need to add a break statement. For each case, I need to add a break, means if this is the case, then execute this statement and stop. Do not do anything else. I add it here again and here. In the default statement, I don't have to add the break statement because it is the last case anyway. When this executes, nothing will execute after it. So let me run with F10, which is step into. Now my program is running. Go ahead and take the user's choice. If I enter the case A, I go back, user's choice is A. So the case is A. Cout, you entered A, here it is, you entered A, and it will break. Now that it breaks, it goes out of the switch statement. Notice if I don't have the break, it will execute the case for A and then the case for B. So A, here it is, it coutted A, then it went through B, couted B, and now it's gonna break. So if I go to my output, I see both statements. That's why you need a break statement. Continue. I'll put my break back and notice now I'm gonna enter something else. So I will stop again. I will run, enter A, B, or C. I'm gonna enter D. Notice the default statement is gonna execute. It's gonna execute because I didn't cover the case for D. The same fashion I did this switch for a character, I can do it for an integer. And that's basically the concept or the idea behind a switch statement. Let me know if you have any questions. So now I will go to chapter 5, which is chapter 5. Chapter 5 is loops and files. So I'm gonna take off all these, then start over. First topic is the increment and decrement operator. The concept behind these operators is to increment by 1, increment a variable by 1 or decrement by 1. For example, if I go ahead and declare a variable integer equals 1, and then I do an integer plus plus. This operator is the increment operator. This is equivalent to the combined assignment that we saw in previous chapter, which is saying L integer equals L integer plus 1, or also equivalent to L integer plus equals 1. So I'm adding 1 to the value of integer. These 3 statements are equivalent, the same thing. They are doing the same thing. In the same fashion, it works for negative. So I can say subtract, which is the same as decrement operator. The way it is right now, actually, let me see out it for you, just so you see it. If I start by 1, then I'm incrementing 1. I'm gonna comment this out. I'm incrementing 1, so this is gonna display 2. Here it is 2 because I incremented 1 to that value. Same fashion, if I decrement, now it's gonna display 0. This, the way it's written, called postfix. So first thing you need to know what the operator does, and then you need to differentiate between 2 cases. The first case is pre-post, which is like this. The increment operator is behind or before the variable. And then there is postfix way. Postfix increment operator is when the integer comes first or the variable comes first and then the operator. The way these are written right now, they are the same. The fact that I don't have anything else in this statement, then both behaviors are the same. It starts to be different when I am including more into this statement. For example, the cout statement. Let me remove all these. Look at this cout statement. I'm not doing anything, so it's going to display 1. Now, if I do the postfix increment here and then cout L integer as is, at this point, I just want to see what the value of integer is. At this point, I'm displaying with an operator. Notice the behavior. I'm going to run. At this point, integer is 1. The fact that it's postfix, as a student, this is how I remembered it. The fact that the variable comes first and then the operator, that means cout statement will use the value of an integer first, and after it's done executing, it will increment it. So notice it will display 1. Here it is the 1, but the value of integer after the execution of this statement is now 2. And that's the behavior for postfix increment. So postfix increment also postfix decrement, will use the value of the variable as is first, then it will increment or decrement respectively. Notice now the behavior of prefix operator. I'm going to move the operator behind or before the variable. In this case, the fact that the operator is before the variable, then it will increment the value first and then use it in the statement. So I will run. At this point before the execution, the value is 1. Then the increment operator will execute, and then the statement will execute, meaning it will display 2. That's the difference between postfix and the prefix. Now it's 2, it will display again 2, and move on. So postfix versus prefix, and increment versus decrement. This is what the book is trying to say in this topic. Then we go to intro to loops, which is 5.2. The concept is a loop is in general is a part of the program that repeats itself. Anyway, in any case that you need to repeat the same code over and over, you better use a loop. For example, enter the names of the students. You enter the first name, then it asks you, okay, enter next student. Then you enter the name of the next student. Then it repeats itself, enter the next student. So it keeps repeating itself. There are a lot of loops in any program. For example, you see this blinking. This is a loop. And as a matter of fact, it's an infinite loop. There is no termination case for this loop unless I close the program. So as long as this program is running, this is repeating itself, blinking, toot, 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 blinking. So before we go over all types of loops, let me go over while loop. And again, just in brief to refresh our memory. But if you have any more questions, read the book, send an email, or send Canvas. The general expression for or format for a while loop uses the term while, then it takes an expression which is true or false. So expression that evaluates to a Boolean. Then I have my statement. Statement as like this, or I can have a block of statements, meaning I can add a curly brace and then have multiple statements. Boom, boom, boom. I can either do one statement without curly braces. If I want to do more than one statement, then I need a curly braces. The expression, I can have any expression, relational operator, logical operator, or just one variable that is Boolean. At the end of the day, this expression must evaluate to a Boolean, whether it's true or false. If it's true, then it will keep repeating itself. While this expression is true, repeat. Once this expression evaluates to false, then it will break out of the loop. So while true, do. While true, do. Example, I can do an infinite loop. I can just explicitly say while true. Then I can say, for example, cout, I am stuck. I'm stuck because it's an infinite loop. Let me comment this out and show you. While true. So while it's true, it will keep going because the condition or the expression, notice the scroll keeps moving down. The expression is true, so it's an infinite loop. If I can break, you will see that, hey, is the expression true? Yes, okay, execute. Is the expression still true? Yes, execute. It will keep repeating itself. This is the general idea behind the while loop. Then you can go in deep about the expression. I can have a logical operator or one bool, for example, L condition. I'm going to say false. Cout, enter 0 or 1. 0 for false and 1 for true. As a matter of fact, 0 is for false or anything else is true. Then I'm gonna cn into my condition, and this operator will do the casting for me, will convert the digit or the number into a bool. So L condition. Now that I took the condition from the user, displaying or executing, run, enter 0 or anything else. If I enter 0, the condition is false, then it will not execute. However, if I enter 10, then the condition is true and it will keep executing. This is one way. Then the book starts in deep about saying that the while loop is a pre-test loop, meaning the while loop, once the control reaches the while loop, it will check the condition first. So pre-test, the test happens before execution. First it tests, then it executes. It tests whether it's true or false. If it's true, then it executes. This is one type of loops. We have two other types. We have a for loop and do while loop. For loop is also pre-test. Do while loop is post-test. Do while loops will execute first and then check the condition. In other words, if you think about it, the do while loop will execute always at least once. If in my case, I'm using a do while loop, which I'm gonna show you in a second. If I use a condition that is false, the do while loop will execute first, then it will check the expression and find it false, then it will break out of the loop. So it will execute at least once. So while loop is pretest loops. Then they mention that infinite loops. We just saw an infinite loop. Then the next topic is about counters. Counters is a way to control your loop. For example, I don't want to execute infinite times or 0. I want to execute a specific number of times. In order to execute a specific number of times, I can have a counter, and my loop then will be called counter controlled loop. For example, int L number of iterations. Number of iterations, 10. I don't need this for now. Maybe I will ask the user later. But for now, number of execution, then I can say while number of if execution is not 0 or greater or equal to 0. While this expression is valid or true, I need you to keep going. If I execute this the way it is, it's an infinite loop. Why? Because this value is not changing. It will keep executing. Here it is. It's executing. Look at the scroll. It's executing. Because this value is always 10 and it's always greater than or equal to 0. So it will always execute. In order to control my loop, I need to start decrementing by 1 on every execution. The fact that this is in its own statement, it doesn't matter if I do postfix or prefix. So now notice when I execute, I start by the loop, it's 10. Then I display. Now it's going to increment. Now it's 9. Is it still above 0? Yes. Okay, again. Is it still above 0? Yes. It will keep doing this as long as the variable is above 0. Now it's 2. Now it's 1. Now it's 0. Hey, is this greater than or equal to 0? Yes. Then break out of the loop. It's still one more or equal. Now that it is -1, it's no longer greater or equal to 0. Now it will break out of the loop. So if I count how many, I'm going to end up with the same count that I started with. So I counter controlled my loop. These are counters from the book. Then they mentioned the do while loop. So while loops are pre-test loop. Then I'm going to take this off. I'm going to keep this as is. I'm going to comment this out. Then I'm going to type the do while loop. The do while loop format is like this. Do curly braces, while expression. In this case, my expression is this, for example. I'm going to use the same expression. Notice I need a semicolon. In do while loops, you have to put a semicolon. Now I'm going to do the same. Take this, put it here. Then notice with post test loop, it will execute first and then it will check. Notice it executed before checking. See out displaying. Here it is displaying, then it will decrement. Now it's 9. Now it will check, hey, is this condition still valid? Yes. Okay, then do it again, all the way to -1. Now that it's -1, it broke out. So it displayed first, then it checked the expression. Post, test, loop, do while. This is how you would use a do while loop. Then the book mentions 5.6. 5.6 is for loops. For loops are as well, I'm going to comment this out. For loops are always counter controlled. The way the format is counter controlled and it's pre-test. So pre-test loop, which is for loop. And the syntax is for, I have initialization statement, then semicolon, then I have expression, semicolon, then I have the increment or decrement, basically the change on each iteration, whatever change you want, whether you want to increment your counter or decrement or any change that you need to do goes in this line. So initialization statement is I need a counter and I'm gonna call it I'll count. The standard is, or the known is I, int I for index. Later, when you start working with arrays, each item is at specific index or subscript. So index 0 is the first item, index 1 is the second item, 2, 3, etc. So I stands for index, semicolon. This is my initialization. I'm starting from 0. My expression is as long as I is less than number of iteration. Number of iteration, I'm going to start with 10. So I start from 0. The expression is as long as I is less than number of iterations. Then the change. What's the change? On each iteration, I would like to increment I. I'm going to remove my comments now so we see it on our screen as one line. Starting from 0, as long as I less than my variable, whatever variable is or user's choice, as long as this true, execute. On each execution, increment. So the control goes like this. Let's say cout I. The control goes like this, reaches this line, then it initializes the first time. Then it checks, because it's pre-test loop, it checks, hey, is I less than number of iteration? Let's say number of iteration is 0. If this is false, nothing happens. If this is true, then it executes. After it executes, it goes to the increment or the change statement. Then it checks again, then it displays, goes to the change, expression, statement, change. So it's like a triangle. Triangle statement, then increment, then check, then execute, change, check. This is how it's gonna keep looping. If I run now, notice at this line, the first time as is 739, which is like junk. Then number of iterations is still 10. It checked, it initialized I, it checked, is I less than number of iterations? Yes, it's still 0. Okay, then execute. Now reaches the end, it will increment and it will check again. Is now that I is 0, it will increment it and it check it again. Is 1 still less than number of iterations? Yes. Okay, execute again. It will keep doing this as long as this expression is valid. Once this expression is no longer valid, means evaluates to false, it breaks out of the loop. So this is the idea for loops. Then there is a topic for keeping a running total. I suggest that you do that code, type it on your and practice it. Then the book mentions files, 5.11. There are types of files. We use files for database. We store data in the file. For example, this is a file, main.cpp. It has this text. When I save and close, it saved the content in the file. If I run again, it loads the data from that file, and we're back to where we left off. So a file is a way or a method of storing values. It behaves like a database. So how do we work with files? How do we work with files? First, it's a library that is provided for us, and it's called fstream. Fstream, file stream, just like input output stream. Input output stream from the display. Fstream means file stream, and it has similar syntax, very close syntax, the same operators, the same everything. In order to start with my files, I can declare an object called fstream, means input stream, or I can do off stream, which is output stream, or I can do fstream. Input stream, input file. Input stream means I need a file object. I need an object that deals with files, and it's an input stream. I need to read from the file. Input means from the file into my program. Or I can do off stream, output file. Or I can do fstream, which is both read and write. For now, I'm gonna do how the book does it. What does the book start with? The book started with writing data to a file. So I'm gonna do off stream, output file. How do I, now that I created my object, I need to open the file. There is a way, which is using my variable that I just created, dot open parentheses demo dot text. Now the fact that I'm doing an off stream output file, if this file doesn't exist, it will create it for me. If this file exists, then it will open it and read its content. Whether it's empty or not, that's a different case. But if the file exists, it's not gonna replace it. If the file exists, it's gonna open it. If the file doesn't exist, it will create it for me and open it. Now, if I put the name of the file like this as is, then the file will be created or expected to be located in main CPP, project, open folder. Then the file is gonna exist here where my program lives. However, I can specify exactly, for example, go to this PC. Where is this PC? This PC, go to C, go to users, go to desk, go to desktop, and then grab the path. If I explicitly say I need the path, remember the backslash, we can't display backslash, so I have to have 2 backslashes. If I explicitly say open from this destination, then it will create the file in this destination. So now if I run and the file doesn't exist, notice on my desktop, it will create the file because the file didn't exist. However, if the file already exists, I'm gonna run again, it's not gonna replace it, it will just open it. So now that I have my file on the desktop, I can, for example, write to it. Remember how we do cout hello from screen or hello in screen and L. I can do the same exact sentence, not same, but similar. I can say, hey, output file, I need you to write out hello in file and end line. If I execute this now, I'm gonna see hello on the screen and hello in the file. Here is the hello on the screen. If I go to my desktop, hello in the file. So I wrote data to the file. This is how I write data to the files. Just similar syntax and everything that goes with this cout, for example, input output manipulators, set widths, set precision, fixed, left, right, etc. All those work exactly the same with the syntax for output file. Then they go to reading from file. So in order to read, I need an F. I'm gonna comment this out. In order to read, I need an F stream. I'm gonna call it input file because this represents my input file. Then I'm gonna say, hey, input file, I need you to open the file that exists in this destination. Now that I open the file and I know for a fact that the file exists, I can just cin from my file. I know the file has a sentence, so I'm gonna create a string l line. Then I can do, hey, l input file. Since I'm reading the entire line, I don't need one word. I'm gonna use get line, just like we saw in our previous chapters. Get line takes two parameters, from to. Where I'm reading from the file. Where I'm reading to L line. Now that I read this line, I'm gonna just see out it on the screen for us to see. Run. It opened the file. It opened the file. It read the line from the file into the line. Then it displayed the line. This is the case for having or guaranteeing that the file exists, but you can never guarantee that the file exists. What if the file doesn't exist? Delete. If I run now, notice it's trying to, let me close. Why do I have this here? Okay, let me close that. Okay. So go open. Get line input file is null. There is nothing in there. And I'm trying to read. I didn't read. So my program will expect, or the programmer will expect a behavior, but there's a logical error. The file didn't exist and I didn't check if the file exists first or not. So when you open an input file, unlike output file, because in an output file, if the file doesn't exist, the system will create it. But in the case for input file, every time you read, you need to read from a file, you need to check first if the file was opened successfully. If you do not do that, that's a big logical error. Okay, so the way to check if the file was opened successfully, you can do if. So stop. Before, right after you open, you can say if L input file, you can check it like this, or is open. You can do it many ways. As long as you do it the way you want, as long as you do it. Otherwise, it's a big problem. So working with files have fixed or specific parts to it. You need to open the file, of course, include the library, create a variable, but you need to open the file, check if a file was opened successfully, then process, then close. You need to close the file at the end of your process. This is just so that you release the file for someone else to use, or some other program or service. If you open the file and you do not close it, then the operating system will have a lock on this file. No one else can open that file because it's being used by other program. I don't know if you've seen this sentence before, but sometimes you try to delete a file or you try to open a file with double click in your Windows. You try to double click a file and then the operating system will say, I cannot delete this file or I cannot open this file because it's being used by another program. So you don't want this to happen. You open the file, you check if the file has been opened successfully, you process the file, and then you close the file. All these steps are as important as each other. Of course, you cannot work with the file without opening the file. So that's an important step. The same level of importance, do not open a file and without checking if it has been opened successfully. That's another second same importance step. Then you need to process the file. How important is that step is as important as opening the file and checking if it has been opened successfully. Closing the file is as important as opening, checking, and processing the file. Now, let's read, well, we did read from the file. Now, imagine I ask you to read a file that you don't know how many lines in it. In this example, I know that I have one line. What if I don't have just one line? What if I have X number of lines? I don't have a specific count. I have X number of lines and I need to process all the lines. So I need to go to each line and read, then jump to the next line, read, jump to the next line. So there is some repetition. So in order to do that, I need a loop. And the best loop in this case is a while loop. I can say while this is being processed the way I want, while input file to integer, for example, I have some integer. Let's declare the integer. Int L integer. Let's say my file has lines and on each line there is an integer. While this is true, while reading is working, while reading is valid, that means there were more data, right? If this fails, that means I reached the end of my file. So this is a good way to detect the end of the file. While this is the case, while this is happening, while this is true, keep going. In this case, for this example, I'm just gonna display. I'm not gonna do anything. Imagine you're reading numbers, you're doing math, you're computing, you're calculating, but in this case, I will just display. So while this is the case, while this is working, show me. Then I will create. Before I create, notice that if I run, nothing happens. Go, go, go. It failed. Nothing happened, failed. Integer is still junk, so close. It's also gonna not do anything. So I will go ahead and create file called demo. Then I'm gonna put in it 1, 10, 20, 100. One on each line. Or I can separate them by space as well. Go, create, open. Well, I should have checked if the file was open successfully. So what I can do is I can recompile by saying input file, yep, is open, close, open curly braces, close curly braces. So recompile. Oh, I can't recompile. Okay, restart. Go. Is the file open? Yes, it was successful. Okay, while into my integer, notice my integer 1, display it. Again, 10, 20, 100. Now it will fail. No more data. Boom, out of the process or out of my loop. Close. If I see 110, the content of the file. So this is how you detect the end of the file. You need to learn about break and continue in a loop. Imagine, I don't know why they mix and match. Like they in this chapter they start with loops, then files, then back to loops. We're trying to upgrade the course to use the 10th edition. Anyway, you need to know about break and continue. Two different two different calls or two different, yeah, two different words or key. Break and continue. Yep. Imagine I have my counter equals 10. Then I have my loop while I'll counter, or instead of having it this way, I'm gonna take it from the user. Int L user choice. Then I can say enter cout, enter your choice. 1, 2, 3, or -1 to exit, something like that. Then I read into user choice. Then I can say while user choice is not -1, means the user chose not to exit. Cout, you chose L user choice. Oh, so well, this case it will break without doing the break. So what I can say is while true, run for infinite. Infinite. You chose this. Then I can say if a user choice equals -1, I can say goodbye. Then the fact that it is infinite, the fact that it's infinite, but the user chose to exit, then I have to break out of the loop. Break, just like a switch. Break. This break will break the loop. Run. So enter 1. Oh, infinite. So I need to increment or reset it. Cout, you chose this. Then I can cout again and enter. So cout this, enter user choice, right? You chose this. If it is the case, break, else I'm gonna display again. So run. So enter. I need 1. Okay, you chose 1. Enter again. I am 2. Enter again. 1. Now 3. Now -1. In case of -1, you chose -1. Goodbye, and it broke out of the loop. In case of continue, well, let me show you at break. When the break happened, nothing after the break happened, nothing after the break executed, and the loop terminated, right? In the case of terminating, it will break. Notice these two statements will not execute. Boom, done. And the loop is done. However, the difference between break and continue will see the body of the loop, and the continue is here. The body and the continue, when this continue executes, everything after the continue will be ignored, but the loop will continue. Unlike break, everything after the break will be skipped and the loop will be broken or terminated. In the case of continue, we will just, or it will just skip the next part, but go back. So run, notice, if I enter -1, if I enter -1, oh, I entered something else, go, -1. Now I am at the continue. With the continue, notice the control will go back to the beginning. Boom. So it skips everything after the continue, but it will continue to the next iteration. For example, let's say I want to display only even numbers, right? So I have a for loop counter controlled int I equals 0, I less than 10, I plus plus. I'm gonna say if I modulo 2 means it's an even, continue. So this will display only odd numbers. Run. Only even numbers. If I modulo 2, continue. Why it's only even numbers? Oh, equals 0. See, if I module 2 is 0, means I is an even number, do continue, means skip the next and go to the next iteration. However, if I do break, it will break out of the loop, it will skip the next statement and also break out of the loop. See, nothing happened. I started as 0 and 0 is considered an even number. It's not an odd number. Then it will break out of the loop. So breaking and continuing. And this is it for chapter 5. Then chapter 6, how much time do we have? So we need, yeah, we can do one more. So functions. Functions, the idea in functions is to break down or break the program to different manageable parts instead of having everything in main. And right now in this course, it's simple. All codes are simple. You probably have maximum like 10, 20, let's say 30 lines. But in an enterprise settings, in professional setting, you have a program that is like million lines of code, maybe more, maybe 10 million. And that's expected. So imagine all 10 millions are in one function. It's going to be very hard to maintain. If I have a function that has 1 million line of code, or let's say 1,000, even 1,000 lines is a lot. Imagine those 1,000 lines, how many parameters they have. And all those 1,000 lines are going to return one, I doubt. So you break down those 1,000 lines of code into different responsibilities. Imagine the function is a worker for you. You're the boss, or this function is a boss function, and it has workers. For example, one function to display, one function to read, one function to deal with files, one function to compute. So every function has one responsibility and only one. This way, if something is wrong in your code, let's say reading from the file is going wrong, something is wrong with reading from the file, then you don't waste time looking in the big function for the code, sorry, excuse me. You don't waste time going over the 1,000 line and looking with a microscope for the code that reads from the file. If you have functions, then you just go to the function that is responsible for reading from the file. It's going to have like 20 lines. So it's easier to debug. So that's the idea. Then they go with the syntax. How do I define and call function? Function call is a statement that causes a function to execute. A function definition, that's topic 6.2. A function definition contains the statements that make up the function. Cool. So a function has 4 parts. A function has a return type. It has, so basically, I'm gonna write it here. This main is a function, and it is the main function, and I can define my own function. The format is, I'm gonna have a return type. Notice type, data type. What's the data type of the return? Return type, function name, open parentheses, parameters list, parameters list. Parameters list means the input. So parameters list, input, or like this, input to the function. So every function has an input. It can have 0 inputs, but if in case it has some input, let's say I have a function called add 2 numbers, right? It takes as an input 2 numbers and it outputs the sum of them. The return would be whatever the type, but it takes 2 and returns 1. So parameters list go here, separated by a comma, and then you have the body, which is curly braces. Body goes here. Body means statements go here. This is the format. So let's say I'm going to start with void functions. Void functions means they do not return anything. they can or cannot take an input, but they don't have to return anything. For example, let's say I have a function that takes a string, and this job or this worker, its only responsibility is to display. So I give it a string and it displays it on the screen. It doesn't have to return anything. In void functions, it's a void my function, or call it display. It takes a string L input. I'm going to call it input string. This function will just see out the input string and do nothing. This is my definition. Then I need to call it int main starts, then it calls the function display, and it gives it some string, hello world. And no, not and L, semicolon. I can either do it like this, or I can take a string from the user. Sorry, let me. A stands for argument. So this is local. Get line or see out to the user. See out. Enter your sentence. Get line from cn into L input string. Then display that string plus ha 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 ha, right? I'm just gonna do an example. So whatever input I give it, in this case, these are not two inputs. These are still one input. I'm grabbing the string, I'm appending or concatenating to it this string. When the flow control reaches here, this is only one. The value of it is in two parts, but it's one input. So go. This is the first call. The first call is hello world. Hello world has been, if I go to call stack, it's coming from this project executable main at line 27. I can double click it and it's gonna tell me where did this call come from. It came from this. Then I can go back. So this line is reading this line and it will end. Now that it ended, I go to the next statement. See out, enter your sentence, get line. Enter your sentence. I am very funny. Funny. Boom. Now it's gonna take this statement, I am very funny, and add to it, ha 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 ha. So if 11, I can step into. You see here, you have a step into. You are stepping into this call. I can either use F10 and it will jump over or step over, or I can use F11 and step into. So in this case, I'm gonna step into F11. Now I am in this sentence. F10, here it is. I am very funny, ha ha ha, as one input. It see out, doesn't have to return anything, continue, and my program is done. So this is a void function. Then I can have a function that returns something. Let's see what the book says after void. After void, they mention function prototypes. Okay, function prototypes. Function prototypes are only the header of the function. It's like declaring a variable and then using the variable, right? You declare the variable first and then you use it. In similar fashion, here I declared and used the function. Function prototypes are only the header of the function. Let me remove these. Let me remove all the comments. Remember how we mentioned the top-down criteria or top-down understanding by the compiler? The compiler goes top to down. The fact that this function is defined before main allows main to use the function. For example, here I declared the variable, then I used it. If I use the variable first, then declare it, it's a syntax error. It's going to say, hey, I don't know what you're talking about. Similar fashion to functions. The fact that this function is above main allows me to use it. If I move it to after main, it's not going to work. It's going to say, hey, you're using a function called display, but I don't know what you're talking about. So the in an enterprise settings under a complicated program, you're gonna see header files and source files. The header files are gonna have the declaration of functions. You're gonna see a function declared in a header file, then defined in a source file, meaning imagine it as a variable. The variable is declared in a header file and then defined, meaning assigned a value to it, used, etc. In this semester, we're gonna define the function before main and then, declare the function before main and then define it after main. So what the book is trying to say, a function prototype is only the declaration of the function. Here, I declared, I don't have to give the parameter a name. I only tell my compiler, hey, you're going top down. Later, in future lines, you're going to see a function called display. I'm declaring a function called display that will be used in future lines. The compiler comes to this line, oh, display. Okay, I know what display is, and it's defined. Here it is. This is what it does. Name for the input. In the prototype, the difference is I can or cannot. I don't need to, but I can put a name for the parameter, but I have to have a semicolon. In the body or the definition, I don't have to have a semicolon. As a matter of fact, I should not have a semicolon. I need to have curly braces and define it. So function header, function body, the entire thing is function definition. Function header with a semicolon is a prototype. This is the prototype of my function. Now this runs fine. Function is declared, function is defined, enter, ha 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 ha. Cool, cool. So prototype, this is the prototype, topic 6.3. Then 6.4, sending data to a function, which we did. We gave an example about sending data to the function. Then we're gonna go by, let me see, since we are running out of time and it's just a revision, we're gonna go over pass by value, pass by reference, and returning from a function. Okay, let's return. Let's say I have a function called add two numbers, and it takes int. It takes two ints, adds them together, and instead of void, it returns an int. Now it's underlined by green. This is not an error. This will allow me to build fine. This will allow me to build fine. There is no syntax error. It's just telling me that the function definition is not found. You're declaring a function, but it can't see it. I don't know what this function is. So I go ahead and define it. I say int add two numbers takes two parameters, a first, a second, open curly braces. Then I'm gonna say return a first plus a second. I can do it in this way, or I can use a temporary variable. So int local temp equal a first plus a second, semicolon, and then return the temp. Run. Well, I didn't call the function. Let's call the function. Let's say add two numbers, 1, 2. I'm adding this, C out. I can do it in this way. Again, because it's a brief. If you are confused, you have a problem, Read the book, send me an email, ask questions, and I'll be more than happy to answer. I can do it this way, or I can use a temporary variable, L temp, local temp. This variable is local to main. This variable, although they're gonna have the same value, but this variable is different than this variable. This variable is local to the function. Once the function reaches the end, which is return, this variable is gonna die. But in this case, they're gonna have the same value. Add two numbers, 1, 2, semicolon. Cout, L temp, and L. So this is one way, and this is another way. Let's say I'm gonna do 4, 5 in this case. F10, I'm gonna step over. So add two numbers, takes 1 and 2. It's 3 now, display 3. Add two numbers, 4 and 5. It displays 3, 9. So as I mentioned, this variable is local to main, but it happened that they have the same value in this example. So this is returning. Then we want to speak about pass by reference and pass by value because it's important. Pass by reference versus pass by reference. Passing by value means, look what it means. Int L first. I'm constructing an example, so I'm not gonna speak while talking until I'm done. So first, I'm gonna say it is equal to 10. Second is equal to 20. Then I'm gonna say display L first, display L second, and after these function calls, I'm gonna cout first, and then cout L second plus in main plus in main. So this is in main. Then I have a function that is called void display. It takes an integer. Then the definition is void display takes an int, and I'm gonna call it a input. Cout in function. So the way this is written, the way we learned so far or we reviewed so far, this is called pass by value. Meaning when I pass first to display, it's gonna copy the value of first and then send a copy to the function. Whatever the function does to that copy, here I'm incrementing the value. So I will receive 10 first. I will display 10. I will increment it, and the function will finish. No matter what the function does to that value, it's not going to affect the original value. Why? Because I gave it a copy of it. I told the worker or the function, here is a copy of what I have. Display it, do whatever you want with it. I don't care. It's a copy. So if I run, notice inside the function, it's going to display 10. It's going to display 20. Then in main, it's also 10. It's also 20. Even though display changed the value. So even though display changed what it received, it's still 10 in the original method. It's still 20 in the original method. This is passed by value. Now pass by reference. Passing by reference means, imagine I have a mailbox and I have a key. The mailbox is the memory and the key is the address. So passing by reference is not copying the value and giving the function a copy of the value. Passing by reference means, hey function, Here is a memory address. There is a value in that memory address. You can access it, change it when it's done. Once you're done with your process, return the control. Here, hey worker, here is the control. Do your task. Once you're done, return the control. And the worker receives a reference to the data, a memory address to the data. Then the function can access that data, do whatever it wants with that data. Once it's done, it returns the control, but the values or the changes will reflect in the main or the boss or the caller method. The value, the memory is still there. The memory didn't disappear. The memory is still there. It has an address. The data in it has been modified. So when I come back to main, I'm gonna see the changes because I passed it by reference. That's the idea. The syntax is I have to add ampersand character. This tells the method that you receive an input by reference. I have to go here and tells it again. You receive this as a reference. Whatever you do in this value will be changed in the original or the boss or the caller method. Look, first is 10, second is 10. First right now is 10. Display will see out 10, will increment 10. Now it's 11. If I go back to the caller, it changed. It's now 10. It's now, sorry, 11. Same to second will become 21. So after the method is done, the original values has changed because this function received the input as reference. It modified them. The memory is still there. Main access this value via memory. So it's going to see the changes. It sees 11, 21. Sorry. Excuse me. So this is passed by reference versus passed by this is passed by reference versus passed by value. We still have 3 topics, but we reached 4 hours for this week, and we need to do only 4 hours per week. So I'm gonna try to move a little faster just so we can cover all the topics per week. So we gonna carry over for next week static variables, local versus global variables, default arguments, and I think you are good for now for that chapter. We don't need to know about this exit function. Okay, so we only have these small topics. I'm gonna start next week with those topics, and I'm gonna go a little faster. If you think I'm fast, again, ask questions, maybe lower the speed on the YouTube video, but the semester is short, so it's not my mistake, really. We have to cover a lot of topics in 10 weeks only. So good luck, and let me know if you need help with the project and the homework.